Hello friends, this video on complex number part 1 is brought to you by examfear.com. No more fear from exam. In this lesson we'll study complex number and quadratic equations, definition of complex numbers, algebra of complex number, that is addition, difference, multiplication and division, identities, modulus and conjugate of complex number, Argand plane and polar plane representation of complex number, quadratic equations. Let's define complex number. Complex number is any number in the form of a plus ib, where a is real and b is imaginary part. Let me repeat. Complex number is any number in the form of a plus ib, where a is the real part and b is the imaginary part. And what is I? I is root of minus 1. I is root of minus 1. Complex number is any number in the form of a plus ib, where a is real part, b is imaginary part and i root of minus 1. For example, 3 plus 2 plus 3i, 7 plus i9, etc. So what is the use of complex number? Complex number are used in scientific fields. Also, if we have two complex numbers and if they are equal, then the real parts are equal and imaginary parts are also equal. If you want to represent the complex number in the xy coordinate, you can represent like this: a in x-axis, b in y-axis, and you get a plus bi. So when I'm saying two complex numbers are equal, only if real parts are equal and imaginary parts are equal. For example, I say z1 is equal to a plus bi and z2 is equal to, let's suppose, c plus di. And when I'm saying that z1 is equal to z2, this implies that a is equal to c and b is equal to d. Now let's discuss algebra of complex number. Two complex number can be added, they can be subtracted, we can multiply to complex number, and we can divide to complex number. We'll discuss all this. That means we can add, divide, multiply and subtract two complex number. Let's take example of addition of two complex number. Let's suppose there are two complex numbers, z1 is equal to a plus bi and z2. Then z1 plus z2 is equal to a plus c plus I b plus d. For example, if we have z1 is equal to 2 plus i3 and z2 is equal to 4 plus i5, we have to add this. Then we'll say z1 plus z2 is equal to 2 plus 4 plus I into 3 plus 5, and this is equal to 6 plus I8. So what we have done, we have added the real part and then we have added the imaginary part. Now the addition of complex numbers should satisfy the following properties. In case of closure law, z1 plus z2 is also a complex number. If you add two complex number, you say z1 is a complex number, z2 is a complex number, then you get z3. This is also a complex number and this is a closure property. You add two complex number, what you get is a complex number. Commutative law, you say z1 plus z2 or z2 plus z1, both will give you the same result. Then we have associative law. When we add z1 z2 first and then add z3, or we add z1 z2 z3 first and then add z1, you get the same result. This is called associative law. Then we have identity. There is a number 0. When you add that number to complex number, you get the same complex number. Similarly, you have additive inverse. That means for every complex number, you have a number minus z. That is, if you add that number to this number, it becomes 0. So for every number, you have a negative of the number. For every complex number, you have a negative of the complex number. And if you add that number to the negative of the number, you get 0. So please understand, we have these 5 properties defined for addition. Closure law, you add two complex number, you get a complex number. Commutative law, you say z1 plus z2 or z2 plus z1, both are same. Associative law, additive identity and additive inverse. Now let's see difference of two complex number. If there are two complex numbers z1 and z2, then the difference of z1 and z2 is, if z1 is equal to a plus ib and z2 is equal to c plus id, then the difference is you subtract the real parts and then you subtract the imaginary part. For example, we have 6 plus 3i and 2 plus I, and we want to subtract this. So what we get is 6 minus 2 plus I into 3 minus 1, and this is equal to 4 plus 2i. Subtraction is similar to addition. Here instead of doing plus, we are doing minus. Let's see multiplication. If there be two complex numbers z1 and z2, then we say z1 into z2 is equal to AC minus BD plus I into AD plus BC. It looks complex, but actually it is simple. Let's take an example. So we have 3 plus I5 and we want to multiply this with 2 plus I6. So what we'll do, we'll write this first. 3 plus I5 into 2 plus I6. So normal simple multiplication. We'll take first number of this, multiply with this. 3 into 2 is 6, plus we'll multiply this 3 into I6. What we get I into 6 into 3. Then we'll take second number of this, that is I into 5. We multiply with this 2, and then we say I into 5 multiply by I into 6. So what we get is 6 plus 18i plus 10i minus 30. Why this is minus 30? Because 6 into 5 is 30 and I is equal to root of minus 1, as we have seen. So I square is equal to minus 1. So I into y becomes minus 1 and 6 into 5 becomes 30. So it is 60 minus 30 plus I into 18 plus 10. So this is exactly what is written here. This is AC, this is minus BD, this is AD, and this is BC. You do not learn this, you can just simply do a multiplication and you will get the answer. This is minus 24 plus I into 28, and this is the answer. So multiplication of complex numbers satisfy the following properties. First is closure law. You multiply two complex number, what you get is a complex number. You multiply, you say z1 into z2 or z2 into z1, it is all one the same. You first multiply two complex number and then multiply a third complex number, or you first multiply second and third complex number and then multiply first complex number to the 8, you get the same result. Similarly, for every complex number you have a additive identity, that is 1. You multiply that complex number with 1, you get the same complex number. There is something called multiplicative inverse. This is important. For every complex number z, there is a complex number called 1 by z. When you multiply 1 by z to z, you get 1. And please make sure z should not be equal to 0, because if z is equal to 0, 1 by z is infinite. Also, distributive law holds true for multiplication. You say z1 into z2 plus z3 or z1 z2 plus z1 z3, both are same. Let's take a problem where we are supposed to find a multiplicative inverse. So we are supposed to find a multiplicative inverse of 2 minus 3i. So if we say z is equal to 2 minus 3i, then from the definition we know multiplicative inverse is equal to 1 by z, and that is equal to 1 by 2 minus 3i. So let's solve this. 1 by 2 minus 3i. We'll rationalize this. So what is rationalization? You divide and add with 2 plus 3i. So what is rationalization? If you have a number in the form a minus ib, so what you do, you add and you multiply and divide with a plus ib. So what happens? A plus ib into a minus ib, if you solve, this becomes a square plus b square. So whatever you get in denominator is not a complex number, it's a real number, and then you get complex number in the numerator. Similarly, if you have 1 by a plus ib, if you want to rationalize, you have to multiply and divide by a minus ib, a minus ib. Similarly, in this case, we had 2 minus 3i. This is an important concept. In this case, we have 2 minus 3i. So we'll rationalize by multiplying and divide by 2 plus 3i. So what we get is 2 minus 3i into 2 plus 3i. That becomes 2 square plus 3 square. Why it becomes 2 square plus 3 square? A plus b into a minus b is equal to a square minus b square. So this should be equal to actually 2 square minus 3i square. is equal to 2 square minus 3i square is nothing but plus 3 square, because I square is minus 1. So that's why we have got this. So this becomes 2 plus 3i divided by this. If you expand this, 2 square, that is 4 plus 3 square, 9 is equal to 14. So this is equal to 2 by 40 plus 3i by 13. 4 plus 9 is 13. 4 plus 9 is 13. So this is the answer. I'll write once again, 2 by 13 plus 3i by 13. This is the answer. To find the multiplicative place, you write 1 by z. So this is 1 by z, and 1 by z, whatever you get, you rationalize, so that in denominator you should give only real number, and here is the answer. Let's take example of division of complex number. So if there are two complex numbers z1 and z2, where z2 is not equal to 0 because we don't want to divide by 0, z1 by z2 is nothing but z1 into 1 by z2, and we know how to find 1 by z2, the way we have found the last example. For example, we have z1 is equal to 2 plus 3i and z2 is equal to 2 plus 2i. We have to divide this. So what we get is 2 plus 3i divided by 2 plus 2i. Now we have to rationalize this. It is in the form of a plus ib. So we'll multiply and divide by a minus ib. That is 2 minus 2i. So this becomes 2 square plus 2 square, as we have seen. And this we have to now multiply. So we'll say 2 into 2 is 4. This into this is 4. And then we'll say 2 into minus 2i. That will become minus 4i. Then we'll say take 3i. 3i into 2 is 6i. And then we'll say minus 3i into 2i. Minus 3i into 2i. So what we get is, this is 4 plus 4 is 8. What here we get is 4 minus 4i plus 6i is equal to 2i. This is minus 6i square. So I square is equal to minus 1. So this will become plus 6. So the answer is 10 plus 2i by 8. Or you can say 5 by 4 plus I by 4. This is the answer. So you have seen what we have done. We have derived a number. We have got this. And now we rationalize this. And then we solve this to get. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.